In cases where a study has a very huge sample size compared to all other studies, or the effect size that they are reporting is drastically different compared to the average of others, that one single study can completely distort the meta-analytic results. So in those cases, if you don't handle the outlier, the final result that you will see would be majorly biased towards that one study. And therefore, it's important to have outlier analysis. Currently, within HubMeta, we have implemented outlier analysis using SAMD, and SAMD is based on in this paper and then follow-up papers, which explain this sample adjusted meta-analytic deviancy statistics. So basically, SAMD is calculated for each study in your meta-analysis and is a measure of how deviant that specific study is from the average of others. So you have the exact formulas in this paper, but in a nutshell, the way it's calculated is you remove one study, calculate meta-analysis using all the others, and then subtract the results with this study and without this study. And that's how you understand how effective this one study was in the whole sample. And this method is clearly explained here. And that's what we have used to calculate SAMD scores. So if you click on any of these results, or if you're in other analysis within HubMeta, you will see the same. You will see SAMD and then another variant of that, which is SAMD-Z, calculated for each of your studies. You can select the threshold for something to be detected an outlier. So for example, if you set that threshold on 5 standard deviations, and in this case, the SD for our SAMDs is 1.59, and 5 times that would give you 8. So if you have an SAMD above 8 or below -8, then it will be counted as an outlier. You don't have an outlier in this case. But if it is indeed an outlier, it would be underlined like this case. In this case, the SAMD standard deviation is 5, and the threshold is set at 3 standard deviations, which is a little bit restrictive, but this is just an example. So 3 times 5 is 15, and as you can see, these are highlighted as outliers, and I can then take a look and see that, oh, of course, look at the sample size. Everybody is in the range of hundreds, whereas this guy has 8,000 of them. Usually, in these cases, you go through multiple steps to handle the outlier. The first thing I like to do is to click on it and go to the actual paper. I will open the PDF, read the paper, make sure, for example, that the sample size is correct. Maybe the correct number was not reported or there is a typo. And then I will go and check the actual correlation table, make sure the number is correctly entered, make sure the directions are right. Now, let's say you are 100% sure that the data entry process was correct. There is nothing to be done about this. And you go back to your analysis, and in the analysis, go back and open the pair, and you have basically 3 options here. One is just do nothing. Be happy with this and accept that there might be an outlier. And specifically when being detected as an outlier is because of huge sample size, I usually stay away from removing this study from the meta-analysis because this is kind of punishing a study for having a huge sample. And I don't want to do that. The second option, as you can guess, is of course to remove this outlier. Simply uncheck this and go down, click on OK. So what HubMeta does is it will recalculate this correlation, and the rest of the table is just the same. And as you can see, it's not an outlier anymore because we have removed it from our study. And the third way is to take these results outside HubMeta, for example, using this code, and use other methods for outlier analysis, other methods for calculating your results. One specific method is using the Morris weights, for example. It's more lenient and uses a more modern approach to outlier analysis or influential studies analysis. We are in the process of implementing that in HubMeta, and when we do that, I'll make sure I'll update this video. After you removed all the outliers and you were happy with the results, make sure you save the final results so that you can always come back to it easily.